Alright, today's lesson is lesson number 63. We're going to be talking about quadratic word problems. So this will involve solving word problems that require using quadratic equations. Okay, it sounds a little complicated, but really most of what we're doing is just plugging in numbers to our quadratic equations, or maybe graphing, just like we've been doing the past couple of lessons, okay? So here are the steps. Like with any word problem, the first thing you want to do is read the entire problem and identify what they're really asking you to find. So figure out what the actual question is. Then you're going to identify the variables. So maybe instead of x and y, for example, they're using height and time. Okay, so time would be your x, and then the height might be the y. Okay, and then you want to replace any values into the proper variables. So maybe they're saying, oh, what happens at t equals 3 seconds? So that's giving you a value for t, so you would plug that in for t. Okay, and then finally, step 4 is to solve. So if it's asking you what's the height when t equals 3, you would solve for h after plugging in the 3 for t. Okay, or maybe the question is asking you to graph, so you would have to find a few points, and then in order to solve, you would just graph the function. Alright, so here's our first example. This is in your guys' textbook on the page mentioned above. Okay, so suppose you see an eagle flying over a canyon. The eagle is 30 feet above the level of the canyon's edge. When it drops a stick from its claws, the force of gravity causes the stick to fall toward Earth. The function h equals negative 16 t squared plus 30 gives the height of the stick h in feet after t seconds. Where is the stick after 1 second and after 2 seconds? Okay, so now that we've read the problem, I can see that the things it's looking for here are where the stick is after 1 second and 2 seconds. And by where it is, they don't just mean like, oh, it's by the canyon. You would need to give the height, right? Because this function is telling us the height after a certain amount of time. So we're just going to plug in those values for t. So I'm going to start by rewriting the equation because it got kind of cut off weird here. So again, our equation is h equals negative 16t squared plus 30. And then I'm asked to solve for t equals 1 and t equals 2. Okay, so those are the two questions I need to answer here. So I'll start by plugging in t equals 1. Okay, so I get h equals negative 16 times 1 squared plus 30. Okay, then 1 squared just gives me 1, so I have negative 16 times 1 plus 30. Okay, and that equals 14. Okay, so we got 14, and this question, again, remember, it's one of the things that it's really asking us for is where is the stick after 1 second. So for our answer, again, since it's a word problem, we should give our answer in a complete sentence. So I'm thinking, okay, where is it then? So where is the stick? And the beginning of the question tells us that the eagle is 30 feet above the canyon's edge. Okay, so we could picture this little canyon, right? And there's an eagle flying above it. And it's 30 feet above, okay? Then we just found that at 1 second, the height of the stick is 14 feet. So it's dropping the stick. And this measurement from the stick to the canyon edge is now 14 feet. Okay, so to write this in a complete sentence, I would say that the stick is 14 feet above the canyon's edge, okay? So similar to how they describe the eagle, right? So after 1 second, the stick is going to be 14 feet above the canyon instead of the original 30 feet that it was above the canyon when the eagle was holding it. Okay? So that's the first part. Now we want to know what about after 2 seconds. So now I'm going to plug in 2 to my equation. So I have h equals negative 16 times 2 squared plus 30. which will give me negative 64, because 2 squared is 4. 4 times negative 16 is negative 64. Negative 64 plus 30 gives us negative 34. And again, that's feet. Okay, so looking back at my picture that I drew, negative 34, right? 0 would mean we were at the canyon's edge, right? But it happened to drop the stick right at the edge, so it'll kind of go right past the canyon, right? So it goes 34 feet in the negative direction, so like further down the canyon. Okay, so think of this canyon's edge as my 0, right? So anything that it goes below that, we would get as a negative height. Okay, so it's falling down like toward the river here. And again, we should give our answer in a complete sentence. It'd be just like this one above, but instead of 14, we would say 34 feet. And then instead of above the canyon, we would say below, right? So 34 feet below the canyon's edge at 2 seconds. Okay. All right, here's our next example. So this is talking about a squirrel in a tree 24 feet above the ground that drops an acorn. Okay, so it gives us the function to model the height of the acorn in feet after t seconds, and we're going to graph. So in order to graph this, I need to make a table. Okay, so I'm going to make my table, and instead of x and y, I'm going to use t and h because those are my variables here. Okay, so this is my table, and h is just going to equal that equation, right? So negative 16t squared plus 24 here. Okay. Alright, but for my points for t, normally I would do the negative b over 2a, right? Find the vertex and go 2 points in either direction. But for this, I'm thinking of the practical situation of this problem, which starts at t equals 0, right? So I can't really go back. I can't have negative time. So for my values for t, I'm just going to look at 0, 1, and 2 for now. Okay, I'm going to see if I can get enough information from those in order to graph this. Okay, so just plugging in 0 for t, I get 0 squared. 0 times negative 16 is 0, and plus 24 is just 24. Okay, plugging in 1, I have 1 squared is 1 times negative 16 would be negative 16, and then plus 24. Oh, sorry, here's in red is the first point. Okay, so I have negative 16 plus 24, and that gives us 8. So my next point is at 1, 8. Okay, and then plugging in 2, I'd have negative 16 times 2 squared, which is just 4, plus 24. That gives me negative 64 plus 24, which is just negative 40. Okay, so I can plot the 1, 8 point, that's right here, and I'm thinking if I go to plot 2, negative 40, I'm way off this graph, right? I'm way down here, way negative. So instead, I'm just going to kind of curve. Remember, this isn't a line. It needs to be a U-shaped graph because it's a quadratic. It's squared, right? So I'm going to just kind of curve my function down, and I'm going to make it go really steep because I know that it's going down. At 2, it would touch negative 40. Okay, but I'm not going to put an arrow here because doing that would mean that it's going to keep going, but for this equation, or this situation, it's dropping an acorn, and the acorn hits the ground. Okay, so once it hits the ground, it's not going to keep going negative height, it's just going to stop there. So I just put a dot here. Okay, and that would be my graph. If I wanted to take this one step farther, I could think about the exact point that this happens, so the exact t value. For instance, I could have the question, at what time does the acorn touch the ground? Okay, so that would mean I'm looking at setting h equal to 0, right? Because I'm looking at the ground, so the height would be 0, and I would set my equation equal to that. and then I would just solve for t. So I'd move the 16t over to the other side, the 16t squared. Okay, then I would divide by 16, and then take the square root of both sides to give me t by itself. And the square root of 24 over 16 I can simplify to be the square root of 6 over 2. And doing that on my calculator, I get that equals about 1.22 seconds. So I actually did my graph pretty accurately. So the point where it hits the ground should happen about 1.2. Okay, 1.22. Alright, so for the next example, it's talking about a firework display, okay, and how it projects the fireworks into the air, and then before they explode and we have the actual fireworks. So this is saying, suppose that we can model one of these fireworks with this equation, and it's asking how long will it take for the star to reach its maximum height, and how far above the ground will it be. Okay, so for the how far above the ground will it be, it's really asking what is that height then, right? So what is the maximum height, right? So what's the height, and how far above the ground will it be when it reaches the maximum height, right? So how high is the maximum height? Okay, the first question is how long will it take for the star to reach the maximum height? So how long, we're going to be talking about time here, and at the maximum height. So what is the time when I'm at the max? Okay, and this is really just going to be the x-coordinate of the vertex. Okay, so our time and height, remember, are just like x and y here. So in order to find the x-coordinate of the vertex, remember I use negative b over 2a. So I'm going to do that here. I'm going to plug in b and a from this formula that I'm given, or this equation, right here. Okay, so I'm going to plug in 72 for b and negative 16 for a. Okay, remember that's going to give me the x-coordinate of my vertex, which in this situation is actually t. Okay, so plugging in 72, then plugging in negative 16, I can simplify this to negative 72 over negative 32, which reduces to 9/4. Okay, so that tells us that 9/4 is the value here. Okay, that's the t value at the vertex, which if you can picture here, right, this is like the parabola, right? So our vertex, that's where the max happens. So this is the t coordinate, right? The x coordinate is 9/4, or we could say 2 1/4, right? 2 1/4. We could also write that as 2.25, right? So for time, usually we don't give time as a fraction, we give it as a decimal. So in answering this question, I would probably say it will take 2.25 seconds for the star to reach its maximum height. Okay, so now for the second part of the question, I'm looking at how far above the ground will it be, so what is that maximum height? And to find that, I'm just going to plug in this t value, right? So this is an ordered pair that's included in my function, so if I plug in t, I'll be able to find what the matching h is. Okay, so plugging in 9/4 to this equation, I get this. Okay, and I basically just have a lot of arithmetic now. So 9/4 squared, I get 9/16, and the negative 16 times 9/16, the 16s will cancel out, so I'm just left with negative 9 squared, which is negative 81. Okay, then the 72 times 9/4 I can reduce. I can divide 72 by 4 and get 18. So this is just 18 times 9, which would give me positive 162. And then the plus 520. Adding those together, negative 81 plus 162, I get a positive 81 plus 520 gives me 601. Okay, so 601 feet. So I would say that the max height is 601 feet above the ground. All right, and that is all for today's lesson. Thank you.